Hello everyone, welcome to Homework Help. If you find the videos useful, please subscribe to the channel. So in this video, we'll solve this problem using the concepts of derivatives. So as per the problem, for f at x equals x squared plus px plus q, find the values of p and q such that f at 1 is equal to 5 is an extremum of f on the interval 0 to 2. And is this extremum a maximum or a minimum value? So let's start with the first part. So we have to find the values of P and Q. And we are given that for x equals 1, the function value is equal to 5. So that means the point 1, 5 lies on this given function. So we can sub in x as 1 and the function value as 5. So we get 5 equals 1 square plus p times 1 plus q. So now we can simplify this equation. So 5 equals 1 plus p plus q. And now we can combine the like terms 5 and 1. So we can subtract 1 from both sides. So the ones on the right side will get cancelled out. So we get 4 equals p plus q. So that's the first equation we get for p and q. Now we are also given that the point 5 f at 1 equals 5 is an extremum of f. So extremum means it's either a maximum or minimum point on the function. So that means it's either a peak or a valley in the graph of the function. So that means at that point the tangent is horizontal. And a horizontal tangent has slope equal to 0. So the next step is to find the derivative of this given function because the derivative represents the slope of the tangent. So we start with prime of f at x equals, now the first term x squared, for the derivative we can use the power rule. So the derivative of x squared will be 2 and then x exponent 2 minus 1. So as per the power rule, we move the exponent to the front and then we subtract 1 from the exponent. And in the second term, p is the coefficient, so p stays as it is, and the derivative of x will be just 1, and q is a constant, so its derivative is equal to 0. Now we can simplify this expression. So prime of f at x equals 2x plus p. So the exponent of x is 1, but we don't write 1 as an exponent. Now the extremum is at x equals 1. So now we can sub in the left side as 0 because at a peak or valley point, the slope of the tangent will be equal to 0 equals 2 times 1 plus p. So this is the equation we can use to find the value of p. So we can simplify. So we get 0 equals 2 plus p, and we can isolate p by subtracting 2 from both sides. So the so the 2's on the right side will get cancelled out. So we get 0 minus 2, which is equal to negative 2. So p is equal to negative 2. Now we can use this value of p in our equation 4 equals p plus q to get the value of q. So we can sub in p as negative 2. Now we can isolate q by adding 2 to both sides. So the 2's on the right side will get cancelled out. So we'll get 6 equals q. So this is the final answer for value of q. So we have answered the first part. Now we have to find whether the extremum is a maximum value or a minimum value. So for that, we'll have to find whether the function is increasing or decreasing on the left and the right hand side of this extremum point. And for that, we'll use the first derivative test. So we can use the number line method. So we can draw a number line, and we are given that the interval or the domain for this function as 0 to 2, and we have to find the whether the extremum point, which is at x equals 1, a maximum or minimum value. So this extremum point divides this number line into two parts. So we'll have to use a test value in each part. So for the left side, we can use the test value of 0.5, and on the right side, we can use the test value 1.5. So we'll sub in these test values in the derivative of the function to find whether the function is increasing or decreasing on the left and right hand side of x equals 1. So we'll use this equation. So the first step is to sub in the value that we got for p. So prime of f at x equals 2x minus 2, because p is equal to -2. Now we'll sub in x as 0.5. So prime of f at x equals 2 times 0.5 minus 2. Sorry, now it's not x, it's 0.5. Now we can simplify this expression. So 2 times 0.5 is 1, and 1 minus 2 is equal to -1. So that means prime of f has a negative value on the left side of x equals 1. That means the function is decreasing on the left side of x equals 1. Now we can do the analysis for the other test value. So prime of f at 1.5 equals 2 times 1.5 minus 2. So prime of f at 1.5 equals 3 minus 2, which is equal to 1. So we got a positive value for prime of f to the right side of x equals 1. That means the function is increasing on the right side of x equals 1. So now we can use these results to find where the extremum is a maximum or minimum value. Now as we go from left to right, the function changes from decreasing to increasing function. So that means that x equals 1 represents a minimum value. So now we can write, so extremum is a minimum value. So we are writing our conclusion. Because prime of f at x changes from positive to, from negative to positive value from left to right. So this can be a conclusion for this question. So these are the steps you have to keep in mind to solve a problem like this one. So if you find this video useful, please share it, like it, and subscribe to Homework Help. Thank you very much and have a nice day. Bye.